Hello, everyone. My name is Allison Jing from the Empathic Computing Lab of the University of South Australia. I'm here to present our work titled eyemR-Vis, using bidirectional gaze behavioral cues to improve mixed reality remote collaboration. In this research, we investigate how sharing gaze behavioral cues can help improve remote collaboration in a mixed reality environment. To do this, we developed eyemR-Vis, a 360 panoramic mixed reality remote collaboration system that shows gaze behavioral cues as bidirectional spatial virtual visualizations shared between a local host in AR and a remote collaborator in VR. As shown in this slide, the local host, which is the user in physical task space, shares and receives verbal and gaze communication cues using in HoloLens 2 to and from a remote collaborator in Vive Pro Eye, while also sharing a live 360 panoramic video via Theta V of his or her surroundings. To synchronize and amplify gaze behavioral cues between collaborators, we have designed 4 different visualization styles shown in GIF format in this slide. First, browsing state, defined as active eye movements such as saccades, blink, or a shift in pink to represent the user's own gaze, and blue to represent partner's gaze. Second, focus state. When the user's gaze dwells on the same point for 500 milliseconds or more. When this happens, gaze visualization turns into a yellow color. Third, mutual state. We switch both collaborators' gaze visualizations into green to indicate joint gaze or gaze overlap. 4, Fixative Circle Map. We use semi-transparent colored circle to map the latest 10 focus locations for each collaborator. As an exploratory study, we paired participants to test the prototype system under 4 conditions that are combinations of 2 factors: gaze behaviors on and off, and on gaze indicator on and off, which we define as bi or unidirectional. The participants also switched their roles after trying each allocated conditions, leading to 4 collaborative task sessions per pair. The order of conditions was counterbalanced. We collected both post-study quantitative questionnaires and preference rankings, as well as qualitative interviews for the analysis of the results. The questionnaire consists of 8 5-point Likert scale ratings on system usability, co-presence, mental load, and interface design. We then applied 1 sample Wilcoxon sign rank test against mid-value of 3 and found that statistical significance in Q1 and Q2, which is about system usability, Q3, co-presence, Q4, attention, Q8, physical effort. Through interview and preference ranking, we also understood that the users prefer bidirectional gaze with behaviors as noted by the users as more immediate feedback and easier to notice, hence making their coordination more confident with less descriptions to confirm. To sum up, the results of an exploratory study on collaborative visual search tasks have suggested that the user have found the system intuitive to use, and visualizations of bidirectional gaze behavioral cues have made the task less physical demanding. With instant gaze visual feedback, the system has helped participants understand each other's focus and joint focus. According to qualitative feedback from interviews, bidirectional gaze visualizations have also made users more confident and sure that their own gaze information is being accurately delivered. In the future, we plan to conduct formal user studies to further explore a number of factors, such as the change of gaze visualization color or shape, the representation of 3D gaze views such as gaze ray, gaze frustum, or gaze arrow, to understand how gaze behavioral visualizations affect pair task effectiveness and the symmetry of the task rows, etc. Thank you very much for your attention. If you have any questions, feel free to contact me. Thank you.